And in that table, I want you to make all your x's in between -2 and 2. So we'll have 5 points that we're trying to find. But that's okay because there's not a lot happening. Make sure we're taking notes at this point. All right, what is this equation telling me to do? Yeah.
Square the numbers.
Yeah, it's just telling me to square all those numbers, right? So what's -2 squared?
4, 4.
What is 1 squared?
1,
What's 0 squared?
0.
Yeah, that's kind of silly, right? What's 1 squared? 2 squared.
4.
What I want you to notice is that you have a repeat of your answers. What caused the repeat of the answers? Yeah, if I square a negative, I get the same answer as if I squared a positive, right? So I'm going to have this duplication because you're squaring. That's what that squaring property gives you. So I'm no longer going to have a line. The lines are gone. At this point, I'm going to have something different. So let's go ahead and plot these and see what they look like. Alrighty, so on the x-axis, we just need to go 2 in each direction. Y-axis, we're going to go up 4. So go -2, 4, -1, 1, 0, 0, then 1, 1, and 2, 4. And if I do all of the points in between, including like little fractions and everything, what you'll find is you get this kind of U shape to your graph. And remember that U shape is created because I'm duplicating all of those numbers. You can see that they just sort of sit right across from each other as we go through. This shape that we've graphed, we call a parabola. Not a parabola, that's like a disease or something. It's a parabola. And all that means is the U shape that was created by the square. So again, you can have the BX and the C present. That doesn't change anything but the location of your graph. That what creates your shape is this specifically that you had that X being squared, because that's what duplicated this idea that it doesn't matter whether I'm squaring the positive or negative form, I get the same answer. Alrighty, so this point right here is the only spot that didn't have a repeat, and we can see that in my table right here. I don't have a repeat there either. And it should make sense because it's 0, right? I don't have a positive and a negative form of 0, so I only got one of them. It's special to us because it helps us graph it. So we label that spot the vertex. Not the vortex, that's something in like sci-fi. It's the vertex. And that is the only point that does not repeat. We have a few other pieces to our graph that are important to us, but I don't really want to keep piling on top of this graph because it's already starting to look a little wordy. So we're going to go ahead and erase this, and then we're going to talk about the pieces that matter today. Because those are the pieces that are going to matter forever, but then on Friday I just add one more little piece to it. Okay? So if you can get these pieces down between today and Friday, then you should be all set for your quiz next week.
Monday?
I believe I put it on Wednesday, if I remember correctly. Because then after that we're reviewing for our benchmark. Alright, so the parts that we care about, and we're going to do a ... for now. Because like I said, on Friday, we'll add one more piece to it, and that's going to tie in the solving that we just finished into the graphing that we're doing. There are two ways that our graphs can look. We can look like what we had before, or you can flip that upside down. The graph that you get depends entirely upon that first number in front. In other words, what does your A value equal? Does your A value equal a positive? Or does your A value equal a negative? So if we're looking at this, there's kind of a nice way to remember this. And so for a moment, I want you to sit and I want you to think about some of those, like, have you ever met like a very, very positive person where everything is fantastic, right? It could be raining outside and flooding your car and something good came out of that, right? You ever meet like those type of people that like everything is glorious, right? Birds are singing, the sun is shining, it's fantastic. And what happens with those positive people that like everything is kind of awesome? They kind of smile a lot, don't they? Okay. Well, then on the flip side, maybe you're one of those people that is like, you know, everything is horrible. I'm in math class right now. The sun is way too bright outside. The birds are way too loud. They just need to stop, right? Everything is horrible. Life never goes my way. And those people, they tend to frown a lot, right? So positive people tend to smile. Negative people tend to frown. Smiley, frowning. Those are the two formats that you can get. In both formats, you still have your vertex. So in this one, our vertex is at, again, the very, very bottom, which means that this vertex is also referred to as a minimum. And hopefully you can see why. It's a minimum because I kind of bottom out at that spot. Over here, at this side, I have a vertex. That vertex is at the very, very top. So we call this particular vertex a maximum. The other piece that concerns me is how to figure out this sort of reflection. And we said that there were points that were across from each other when we graphed the last one. So if we look at that, we have this imaginary fold line that cuts through the vertex and goes down our graph, in which case every point that's on the right-hand side of that will be the same distance on the left-hand side of that. We call that imaginary line the axis of symmetry. And what the axis of symmetry does is it cuts my graphing in half. It actually gives me a way to graph these without having to build a table at all, really. And then the last part that we're going to talk about as far as what I would like to see is that we also want the y-intercept. And coming out of the graphing of linears, what do we know about the y-intercept? Yeah. It's where I cross the y-axis. So what do I know about the point if I'm crossing at the y-axis? X is 0. So your ordered pair would be 0, comma, some number. You can never forget that. I will be asking you that question all the way to May, because it literally comes up every time we graph. All right. The problem is that our equations, the way that they can ask you to graph them, can come in different forms. And this changes how we graph it. So today we're only going to do 2 different forms, and then tomorrow we'll have a very small lecture on the last of the forms. All right. Can I erase so that we can jump right in? Huh? No, they cannot go sideways. That would not be a function. Are we good now? Huh? A graph, that's not a function. Yes. All right, first form is standard form. Standard form is pretty much the way that you've seen these all the way up until now. That is y equals ax squared plus bx plus c. So when we do this, what we're going to do is do the generic steps on the left and then the specific problem on the right. So step number 1, we have to determine if it opens up or down. What that means is if I'm in a smiley, meaning I open up, or if I'm a frowny, meaning I open down. So on the right-hand side, we're going to do this on our example, which is y equals 2x squared minus 8x plus 6. Heads are off of our desk, guys. Thank you. All right. Now, this one sounds kind of silly, and it's really not used in my graphing of it. But where it becomes important is, let's say you're taking your benchmark and you have an A, B, C, D. If you can tell whether it opens up or down, normally that limits you down to 2. Sometimes it gives you your answer right there and you don't have to do anything else. Okay? So it's really important to look at and to be able to tell that. So your opening up or down depends on your A value. So what is my A value here? It's positive 2, which means how do I open? Yeah, I'm a smiley face. Step number 2 is going to be the y-intercept. Head is still off of our desk, please. Y-intercept you have 2 options for. So we're going to leave a little bit of a blank here because you have a shortcut. But we're going to go ahead and find it with what we know about a y-intercept. And that is that I can go ahead and plug zeros in for the x's. So I have 2 times 0 squared minus 8 times 0 plus 6. What is 0 squared? Times 2? 8 times 0 plus the 6. But that kind of just cancels everything out in the front, and I'm left with just a 6 there. That gives me the ordered pair 0, 6. What I want you to notice is that that meant that I canceled 2 pieces out. At this point, I have like 3 or 4 people I would make stand who are either not taking notes, eyes are closed, heads are on the desks. Needs to stop, otherwise I will make you stand to make you stay awake. Is he even awake? All right. Taking notes. Canceled out the first 2 with the x's, which means if I'm in standard form, then that will always be your C value. Number 3 is going to be the vertex. In standard form, you have to find your vertex by doing a formula. That formula is going to be x equals negative b over 2 times a. What does that remind you of? Yeah, it's your quadratic formula. It just doesn't have the square root part. But that should make sense because your vertex does not repeat. The only place the quadratic does not repeat is if your square root was 0. So this is the quadratic formula without that square root, where that square root was 0. But that only gives me half of it. To get from there, I have to plug in. So you're going to have to plug in that x value in order to get the rest. I already have like a couple on my desk.
You do.
Oh, that's good.
Can you pass out what's out?
Mm-hmm.
Okay, thank you.
Alrighty, so if I come over here, what is my A value? What is my B value? Negative 8. So let's plug that into my formula. That gives me x equals a negative of a negative 8 gives me 8 over 2 times 2. 2 times 2 gives me 4. 8 divided by 4 gives me 2. Again, that's only half of your vertex. In order to find the other half, you'd have to go all the way back up to the original problem, and we're going to replace the x's with a 2. So I get 2 times 2 squared minus 8 times 2 plus 6. 2 squared gives me 4. Remembering order of operations, the exponent comes first. Then I multiply. So that gives me 8 minus 16 plus 6. Add everything together, and you should get a negative 2. That gives me a vertex at the ordered pair 2, because that's what I found in the formula, comma negative 2, because that's what I found when I plugged it in. The last step is going to be to label the axis of symmetry, because we're going to use that in order to graph this. So on our graph, we need to make sure that we're going up to 6 and then putting a dot. We're going to go to 2, negative 2, and put a dot. But I do not have enough dots to connect my dots here. So what's going to happen is I'm going to draw my axis of symmetry. Remember, that's a vertical line that goes all the way through the vertex. As I'm looking, this point right here is 2 to the left of this imaginary fold line, which means I have another point at 6 if I go 2 to the right of the fold line. That would be over at 4, 6. If you don't believe it, plug in 4, and you'll see that it comes down to 6 as well. Now I can go ahead and connect the dots and form my view. On your homework tonight, you are expected to try your steps. If you walk in with nothing on there done, then that means you're not giving me any kind of effort with it. At the very least, you should be able to tell me up and down. You should be able to tell me y-intercept. From here, I don't care if you mess it up, because you'll learn more by doing that than by not doing it and then just copying it if we go over it. Okay? So the expectation, you only have 4 problems tonight. I'm not done yet, by the way. You only have 4 problems tonight, which means that I am expecting you to try them. Okay? Any questions with standard forms? We have one more format to cover today. All right.
Wait. Never mind. I was good.
You sure? Well, all the work is there.
Yeah, I did it the first time.
The 4th step was draw or label the axis of symmetry. All right. Second format, I guess I don't need a label, is vertex form. Vertex form looks a little weird. So this one is y equals, we still have an A, and then we're going to have a parenthesis, x minus h, parenthesis squared, plus k. All right, so as I go through this, step number 1 is going to be to ask whether it opens up or down. So what's my, and then my example. So my example is going to be y equals -1/2 x plus 3 squared plus 4.
Would that be going down?
Yeah, what's my a value?
Negative 1/2.
-1/2. So because it's a negative, yes, we are opening down, frowning face. Step 2 is the y-intercept. Now in standard form, you have sort of a shortcut where you would have a c value. There is no c value here. So your y-intercept, you will have to plug x equal to 0. You cannot get away with not doing that. So if I do that, I would have -1/2 times 0 plus 3 squared plus the 4. 0 plus 3 is 3. Square that, because I always have to square before we multiply, and I get 9. -1/2 times 9 is -9/2 plus 4. -9/2 is -4.5, which means that I get a -1/2 for that value. That gives me the word pair, 0, -1/2.
Why is it 0?
Because we plugged 0 in for x. So your y-intercept will always be 0, and then whatever number you got as a result.
So no matter what, for
The y-intercept, x is 0, yes. All right, step number 3 is going to be the vertex. Now, in standard form, we didn't really have any work that we had to do for the y-intercept because you can kind of cheat your way through that, but we had to do work for the vertex. In vertex form, you have to do the work for the y-intercept, but the vertex, you can cheat your way to. Vertex will always be h comma k. What I want you to notice is that h is the opposite sign of what you see in the parentheses. So if you see a -2, that h is 2. If you see a +2, that h is -2. It's always opposite than what you see. So if I'm looking at my vertex here, the numbers in the h and the k position are a 3 and a 4. Change the sign of the 3 only, and I get a vertex at -3, 4. Four is to label the axis of symmetry.